Good morning, everybody, and welcome to today's lesson, Volume of Prisms. So make sure you have your notebooks out, and let's get ready to go. First vocabulary word is prism. We're talking about a geometric solid with two parallel faces called bases that are exactly the same size and same shape. And we have all drawn prisms at some point in our lives. You've made them. They look relatively cubish. And this one may not be the best, but at least you'll have a pretty good idea of what they would look like. A three-dimensional object. Now, what's interesting about the 3D objects is what's interesting about the 3D objects is there are certain points on a three-dimensional object, some things that you guys need to understand and need to know. First is, if I look at the area that's in between these four dots, the front four, that is called what's called a face. And a face is simply a plane on a cube, and you can see this cube, or a plane on a prism. You can see this cube is made up of 6 faces. We have one here, one on the bottom, one on the back, one on the left, one on the right, and one on top. And then you'll also notice that these faces also have lines that intersect them, or those points. And those lines have names. Each of those lines is called an edge. So we have faces, which is the space in between the edges, and we have the edges, which is the sides of each face. And you'll also, lastly, you guys, I want you to notice that the edges meet at those red dots, which I'm now coloring white, and those dots are called vertices. And a vertex is just simply a place where each of the 3 edges intersect. That's the location where they each intersect. So that gets us kind of the vocabulary that we're looking at for today. And oh man, alright, back to, I hit the wrong button, but that's okay. The other vocabulary that we need to talk about is that the fact that all the faces connect to bases are parallelograms. Finally, it's volume, and the volume is a measure of how much space a solid object takes up. It's usually measured in cubic units. Sometimes it's in cubic centimeters, sometimes it's in cubic inches, maybe even in cubic feet. What I mean by cubic units, it means if it is in centimeters, it's going to be centimeters to the 3rd power. If it's in inches, it's going to be inches to the 3rd power. Everything in volume is always measured in cubic units, or units to the 3rd power. Lastly, let's take a quick look at what some of these 3D shapes might look like. And I did this before, and I kind of like the idea of it. We're going to go ahead and paint the bottom part of my shape pink, so that way you can at least kind of get a better idea or a better picture. You can better see. I'm going to dim this so that we can actually see through it slightly. So now what I want you to focus on is the pink part of my square is on the bottom of my shape, and the orange part is on the top. And now all I have to do is connect those shapes together with a dotted line. And I'm going to use a white dotted line, so now it'll be easier for you guys to see what connects to what. And now we have a three-dimensional shape. So we have our 3D shape where the pink part is on the bottom. That's my bottom face. The yellow part is on the top face. I have a face on this side, a face in the back, a face on the other side, and a face at the bottom. I guess if you look at it long enough, you can kind of flip it around and see how it looks. We'll do the same thing for a rectangle. We'll move it, maybe this one will make it, I think we can do something like this. So again, I want to kind of dim that just a little bit so we can kind of see. And let's paint that bottom pink. So now the pink part is going to be on the bottom. Or you can even look at this one and say, okay, well, the pink one's maybe on the back. Maybe that'll be easier for you to visualize. And when we do that, we can connect those using our connector tool. And we're going to connect those like this. Here, 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 and here. So again, maybe this time it's easier to say, okay, well, the pink one looks like it's on the back, so this one might be a rectangular prism that's been laid down flat. You can do the same thing with triangular prisms as well. We'll go ahead and make one of those too, and this one will make kind of large just so we can see. And again, I want to, we'll identify that one as our bottom, maybe as the back, I guess you could say it too. And then we'll just connect those using our connector tool with a couple of dotted lines. And what's neat about triangular prisms is that they actually form rectangular faces as well. So this is a big rectangular face, the black rectangular face on the side, and then there's a really thin one. It's kind of hard to see because of how I did everything, but you can see that rectangular face there. So just to give you an idea of what 3D shapes look like, now we want to talk about calculating the formula for a volume of a prism. And we know that the formula is big B times little h. And the way that breaks down is V equals volume, big B equals the area of the base, and h is the height. So now let's go ahead and create our 3D object. We'll make it kind of big this time, just so that hopefully it'll be easier to tell. And we'll put it this way, and let's go ahead and paint the bottom layer this time pink. We'll kind of dim that down a little bit, and then all we got to do is connect it. And connecting it's really easy to do. We're just going to kind of go from this corner. Whoops, I got the wrong shape. One more over. There we go. And this time we'll connect from this corner to this corner, from here to here, from this one to this one, and from this one to this one. So now, as I'm looking at this shape, I am looking at the top of it, which is my pink side. Maybe, no, not pink, the yellow side, the yellow section of my prism. And I want to be able to identify the fact that this is the top and the pink one is the bottom. And if I look at the bottom, I'm going to say that this side is 3 centimeters. And I want to say that this side down here is also 3 centimeters. And let's say it is, let's just go ahead and say, well, maybe this is 12 centimeters high. So it's 3 centimeters wide, 3 centimeters long, and 12 centimeters straight up. Now we want to use this formula, area equals capital B times H, where capital B is actually the area of this pink section. Since that's a square, it's a parallelogram, we know that the area of a parallelogram is its base times its height. Here's the base of my parallelogram. It is 3 centimeters. Here is the height of my parallelogram. This is just the pink one now, and it is also 3 centimeters. And when I multiply those two together, I get 9 centimeters squared. So that is big B. That's the area of the base. I go over here and use this equation then to solve for volume. If big B is 9 centimeters squared, the area of my base is 9 centimeters squared, I'm going to multiply that by how high my prism is. If this section is the top, well, the height is going to be 12 centimeters. So I multiply that times 12 centimeters. And then I'm going to go over here and do the math. 12 times 9. 9 times 2, 18, carry your 1. 9 times 1 is 9, plus 1 is 10. I get a volume of 108, and here's the important part, centimeters cubed, because centimeters squared times centimeters is centimeters to the 3rd power. So that, boys and girls, is how you are calculating volume of a prism. Sometimes your textbook might give you what the area of the base is. They might say, hey, this is already 9 centimeters squared. Then it's easy. The math is easy. All you got to do is multiply your 9 centimeters times your 12 centimeters height. 9 centimeters squared times 12 centimeters high is 108 centimeters cubed. So I do want to remind you that every single problem you do, you must show all your work. And the way we try and show all of our work is we try and use 3 steps. Where step 1 is rewriting the equation. Rewrite it. Just rewrite it. Write it again. Step 2 is I want to plug in my numbers. Plug plug in all my numbers for all my answers. And step 3 is to actually do the math and solve it. So, good luck. Hope you guys enjoyed the video. Don't forget to fill out your Google form to give me the proof that you actually did the video. And I hope you have a good day, and we'll work on this again over the next couple of days. Don't forget, tomorrow we are taking a probe.